Welcome to MLAC online tutorial. Now let's consider this trigonometric identity that says prove that 1 minus tan²θ all over 1 plus tan²θ equals, now in bracket, open bracket, cosθ plus sinθ close bracket, open bracket again, cosθ minus sinθ. Alright, for us to proceed, what we just need to do, now let us recall that tan² is sinθ over cosθ. Alright, if this identity is true, then let us now implement it into this. Alright, now take note that this is square, so here it implies that tan² will give us sin² over cos²θ. Alright, now let us now plug in this for tan²θ. So here we have that 1 minus, now for the numerator you have sin² over cos²θ, then everything all over 1 plus sin² over cos²θ. Alright, resolving this, now take note that when you have 1 minus a over b, now for us to resolve this to a single fraction, this is b minus a over what? B. Okay, so just multiply b by this, or in another simple term, this 1 implies 1 over what? 1. Then the LCM is what? B. Here you have 1 in b is b, times 1 you have what? B. Now b in b is 1 times a, so that resolve that for a single fraction. Okay, so if you tend to apply that here, so this becomes cos² minus sin² all over cos² plus sin² all over cos². Alright, sorry, I guess there was an error here. Sorry, so this should be, sorry, let me write this here. Let's come up here. So this becomes cos² minus sin² all over cos², everything over cos², then plus sin² over cos². In case you might probably be confused, this is what I mean here. 1 minus a over b will give us b minus a over b. This is just to a single fraction. So here, now let us also consider this algebraic expression where we have that a over b all over c over d. Now this implies a over b now divided by c over what? D, right? Now, and if we want to change this to multiplication, what we just need to do is to flip this, or we'll find the reciprocal of c over d, and this will give us a over b times d over what? C. Now if this is true for the algebraic expression, we can now implement that to this. So here, let us represent this as our a, represent this as our b, represent this as our c, and represent this as our what? D. Now final product here will now give us cos² minus sin². Now that is for a, then over, then our b cos². Now times, now our d here is cos², then all over our c here, which is this cos² plus sin². Now to this point, you can now say this will eliminate this. You are now left with cos² minus sin² all over cos² plus sin². Alright, moving further here. Now let us also recall this trigonometric identity that says sin² plus, sorry, cos² plus sin² will give us what? 1. So it implies that this denominator here all tends to what? 1. So, and also recall that when you have from algebraic expression the difference of two squares, this will give us a plus b, a minus b. Now if this is true, we can actually make it possible here, or employ it here, that our a is, okay, let me just bring it out here so for clarity, minus sin²θ. Now take note that the denominator already is what? Is 1. Alright, now if this is, if a square represent this and b square represent sin²θ, it implies also here that here you have cosθ now plus sinθ according to this first expression, then into to the second one. Now you have what? Cosθ, then minus sinθ. Now this is whereby we make a equals cosθ and b equals sinθ. Alright, you can see that we've just proven that 1 minus tan²θ over 1 plus tan² equals to this expression, which is similar to this. Alright, that is the solution. Now if you love what I've just done, kindly subscribe to my YouTube channel, and ensure you click on the notification button to be notified of all my videos in math, physics. Thank you and God bless you.